Hello, guys. For 9.3, we are only covering the last part, which is calculus of matrices. This is very simple, so I'm going to go over this pretty fast. So let's say we have a matrix A of t with independent variable t. That looks like this, right? So we have some matrix, and then each entry is going to be some function of t, right? Up to a1n of t, and then am1 of t, and amn of t, right? So we have a matrix, and all the entries are just some function of t. And to define the differentiation of matrix A, right, at some point t naught, that is, we want to evaluate A prime at t naught. And that's the same thing as taking each entry and take the derivative of it and evaluate it at t naught, right? So it's very simple, right? To take the derivative of a matrix, you just take the derivative of all the entries, each entry, one by one, right? And then the antiderivative, the integral going from A to B of the matrix A of t dt is defined as similar to differentiation, right? You take the integral going from A to B of each entry, ai jt dt, right? That's it. Okay, so let's just take a look at some example. Okay, so our first example, we have A of t, 2 by 2 matrix, right? And you can see that each entry is some function of t. All right, so part A, we want to find the derivative, right? So to find the derivative of the matrix, right, all you need to do, right, is take the derivative of each entry, right? So the first one is 2t, second one is negative sine t, e to the t, and 0, right? And that's it, we're done, okay? And let's look at part B, right? We want to find the integral of A of t going from 0 to 1, right? Now this one might take a little time, right? So 0 to 1, A of t dt. That means we want to take the integral of all the entries, right? T squared plus 1 dt, right? And then the second one, 0, 1, cosine t dt, okay? And then 0, 1, e to the t dt, and then integral 0, 1, 1 dt, right? Just like that, right? Take the integral of all the entries one by one. Okay, and then we have something like this, right? And all you need to do is evaluate them, right? So let's see, that's 1/3 plus 1, that's 4/3 minus 0, so 4/3, right? Sine of 1 minus sine of 0, that's just sine of 1. E to the 1th power, and then minus e to the 0, so e minus 1, and then here we just have 1 minus 0, which is 1. Okay, and that's it. That's the integral of a matrix. Okay, and next we're going to talk about some differentiation formulas for matrices. They are very similar to the regular differential rules that we saw in Calc 1 and Calc 2. Right, so the first one, let's say we're taking the derivative of C times A, right, where C is a constant and A is a matrix, right? And that's the same thing as taking the constant C multiplied by the derivative of A with respect to t, right? So C is a constant, okay? All right, and then the next one we have addition rule, right? So take the derivative of the sum of two matrices, right? That's the same thing as taking the sum of the derivative, right? And last but not least, we have the product rule, right? The derivative of the product is A dB dt plus dA dt times B. Okay. Now notice that the order of matrix A and B here matters because, again, remember we talked about this, that a matrix multiplication is not commutative. So the order of A and B in here matters in here as well, right? So we have A first and then B. So A first and then the derivative of B, and then derivative of A multiplied by derivative of B. Now, of course, addition of matrices is commutative, so it actually doesn't matter if you put this one first or this one first. Okay? You will get the same thing. But just remember that for multiplication, the order of matrices matters. Okay, and that's 9.3. We're just having this new stuff. Thank you.